welcome back to Pachehra Talks. My name is Arun and I'm Solutions Architect MCT with Novintech, which is one of the best organization to work with. Also received many Great Place to Work awards. And today we are going to talk about Azure DDoS service and a lot other relevant stuff. We'll share the agenda soon. And this is my channel, and these are my views on the topic. So let's start with the agenda. As you can see, we need to understand first, before we go ahead and dig the service, what is that service is all about, what it means, what is DDoS attacks. I'm pretty sure you guys are familiar about it, but we have to cover it to connect the dots. First, we need to understand what is DDoS attacks, and then the types of DDoS attacks, and then finally how Azure offering is helping us, and if it is helping us completely, or do we need to take the help of another Azure services uh, along with the Azure DDoS. Then we'll see the comparison between the different Azure DDoS services, and finally all the key features that it offers, and then we'll see how can we enable it from the Azure portal, and then we'll discuss the pricing and some relevant stuff which can help us to choose the right offerings for our environment. So let's quickly understand what is DDoS attacks. Well, imagine you are driving on a highway to get to work. Normally, the traffic flows smoothly and you reach your destination without any issues. This highway is like the internet, and your journey to work is like a request from your computer to a website. Now, picture a DDoS attack as a sudden influx of thousands of cars. As you can see, let's suppose the red one is you. Thousands of cars flooding the highway, all trying to get to the same exit, just like you. These cars aren't really going anywhere. They've been sent by someone who wants to create a traffic jam. The result? You stuck. And who is the real traffic? That's you, right? So in your car, uh, you would not be able to move here and there. Even if you will to move, the point is you need to reach destination. Unable to reach your exit because the road is overwhelmed with vehicles that have no business being there. In the same way, a DDoS attack floods a website with so much fake traffic that legitimate requests can't get through. These cars, in our analogy, are actually packets of data, and the someone sending them is usually a network of compromised computers controlled by an attacker. Just like the highway wasn't designed to handle that many cars at once, many websites and online services aren't unequipped to handle the massive spike in traffic that comes with the DDoS attack, leading to slowdowns or complete outages of the service. So, a DDoS attack is essentially an intentional effort to clog up the pathway that lead to a website or online service, preventing legitimate traffic from reaching its destination, much like a malicious traffic jam on the internet highway. So, if we need to, I believe this analogy help us to understand what it is, or we can just say in DDoS attack, the app server gets so overwhelmed with fake traffic that it can't handle requests from real users. This means the app either can't serve its real users, or the real users can't even reach the app server to use the service. Either way, the service is compromised, leaving the app unable to function for those who genuinely need it. All right, so we can take another analogy just to make a point. For example, imagine you're running a restaurant, because there are multiple kinds of attack. That's the reason I'm trying to give you another analogy for a different kind of attack. The one where this one, which we are representing, more or less like L3 or L4 attack. Now, imagine you are running a restaurant known for its made-to-order pizza, each requiring careful preparation and cooking time. On a normal day, orders come in at a steady pace, allowing your kitchen to keep up while maintaining quality. You with me, right? It's very simple example. Now, how the attack begins? One day, let's suppose there is a rival decides to disrupt your business. They hire a crowd to flood your restaurant. Instead of genuine customers hungry for pizza, these are actors who've been told to place complex orders and then cancel them at the last minute or ask endless questions about the menu without ever ordering. So how does it actually relates with the L7 attack? Because the first example was L3 and L4. So in this scenario, L7 DDoS attacks on a web application, how can we relate it? Rather than simply flooding the restaurant or website with a mass of people or traffic, the attackers engage this service in a way that's intended to consume as much attention and resources as possible. They make requests that seem legitimate but are designed to overburden the system. So, what would be the impact? Just as your kitchen staff becomes overwhelmed trying to manage these fake orders, leaving real customers waiting and frustrated. A web server targeted by an L7 DDoS attack struggles to handle the flood of malicious requests. Legitimate users experience slow service or can't access the website at all because the server resources are tied up handling the attack traffic. That's the reason I was saying earlier, in a DDoS attack, the app server gets so overwhelmed with fake traffic that it can't handle requests from real users. This means the app either can't serve its real user, or the real user can't even reach the app server to use the service. This was the real user and it can't, okay, reach the app server. Either way, the service is compromised, leaving the app unable to function for those who genuinely need it. So now we understood what exactly denial of service is. DDoS, denial of service, right? So these attacks are denying so that legitimate users can get the service. So how does attack actually works? Well, uh, this attack carried out with networks of internet connected machines, because you have to create that kind of traffic jam, right? These networks consist of computers or devices which have been infected with malware. Usually that's how it proceeds, allowing them to be controlled remotely by an attacker. These individual devices are referred as bots, and a group of bots is called botnet. Net stands for network, botnet, right? So once a botnet has been established, the attackers is able to direct an attack of sending remote instructions to each bot. When victim server or network is targeted by the botnet, each bot sends requests to the target IP address, potentially causing the server or network to become overwhelmed, resulting in a denial of service. For example, here is the attacker. He created the botnet and sent the traffic to the web server. So denial of service to normal traffic. Because each botnet is a legitimate internet device, separating the attack traffic from normal traffic can be very difficult. That's why there are lots of DDoS protection available in the market, and ours is Azure. So we're going to talk about the Azure. But before we go and talk about Azure DDoS services, let's see what are the symptoms, right? The most obvious symptom of DDoS attack is a site or service suddenly becoming slow or unavailable. Why we are talking about symptoms? Because each bot is a legitimate internet device. Separating the attack traffic from normal traffic is very difficult. So we need to figure it out through the symptoms. Are we under attack? The very first is service suddenly becoming slow or unavailable. But since a number of causes, such as legitimate spike in traffic, can create similar performance issues, further investigation is usually required because we want to find the right cause of this symptom. So, traffic analytics tools can help us spot some of these symptoms in a right way, or whether it's a DDoS attack or not, help us to figure out. So, suspicious amount of traffic originating from a single IP address could be uh, a symptom of DDoS attack. Once we have those traffic analytics tools in place, we can figure it out from where the traffic is originating. A flood of traffic from users who share a single behavioral profile, such as device type, geolocation, or web browser versions. So similar traits can help us figure out, okay, these botnets are sending the fake traffic. An unexplained surge in request to a single page or endpoint because they know only one thing, so they are diverting everything at one place. Or old traffic patterns such as spikes at odd hours of the day, or patterns that appear to be unnatural, spike every 10 minutes. So these are various symptoms which can help us identify if we are under attack. So what are those kind of attacks? Well, they are common DDoS attacks that we have highlighted here. It usually attacks layer 7, 3, and 4. So while nearly all DDoS attacks involve overwhelming a target device or a network with the traffic, attacks can be divided into three categories, right? Because there is one target device, the device is so much utilized or overwhelmed by the request, or the path by which we are reaching to the device is totally occupied. That's why two analogies at the beginning: the highway analogy where traffic is jammed, or the restaurant analogy where the service was overwhelmed. So an attacker may use any one of those attack vectors. So let's take an example of an application layer attack. The goal of this attack is uh, sometimes we can call it layer 7 attack. Okay, the goal of these attacks is to exhaust the target resources to create a denial of service. The example of restaurant one. The attack the attacks target the layer where web pages are generated on the server and delivered in response to HTTP request. A single HTTP request is computational cheap to execute on the client side, but it can be expensive for the target server to respond to, as the server often loads multiple files and runs database queries in order to create a web page, right? For example, these are the bots sending, but this has to work a lot of work. So what would be what would happen? Denial of service if it has to work too much for the unlegitimate traffic. So layer 7 attacks are difficult to defend against, since it can be hard to differentiate malicious traffic from legitimate traffic, right? That is the main idea behind this DDoS attack. You need to identify and then shoot. If you have seen the movies where everybody is wearing the black hat, now you cannot see, or black coat, now you cannot see or identify who is the actual victim. Now everybody looks the same. So that was the challenge. That is the challenge. Now let's take an example of HTTP flood. This attack is similar to pressing refresh in a web browser over and over on many different computers at once. Large number of HTTP requests flood the server, resulting in denial of service. This type of attack ranges from simple to complex. Simpler implementation may access one URL with the same range of attacking IP addresses, refers to user agents. Complex versions make use a large number of attacking IP address and target random URLs using random refers and user agents. Right? So that was all our HTTP or layer 7 attack. When you can take another example of protocol attack. Protocol attacks, also known as state exhaustion attacks, cause a service disruption by over-consuming server resources or the resources of network equipment like firewalls and load balancers. Protocol attacks utilize weaknesses in layer 3 and layer 4 of the protocol stack to render the target inaccessible. That was our highway example. Let's suppose there was the bandwidth that was completely utilized by fake cars. And SynFlood is a wonderful example for this, which is like, let's try to construct a story here. A SynFlood is a, let's suppose, an analogous to a worker in a supply room receiving requests from the front of the store. The worker receives a request, goes and gets the package, and waits for confirmation before bringing the package out front. The worker then gets many more packages request without confirmation until they can't carry any more packages, become overwhelmed, and requests start going unanswered. This attack exploits TCP handshake. That's why I was trying to put it out there like this. The sequence of communication by which two computers initiate a network connection by sending a target a large number of TCP initial connection requests, SYN packets with spoofed source IP addresses. The target machine responds to each connection request and then waits for the final step in the handshake, which never occurs, exhausting the target's resource in the process. All right, so these are two kinds of attacks. Similarly, there is another one like DNS amplification. But ultimately, the point is what attacker is doing, attacker is trying to exhaust the resource or the services of the resource, right? Like the L3 and L4, the bandwidth or the application server itself, the application layer 7. Okay, now I think that is good enough about the DDoS attacks. What are those? Now it's time to understand the Azure DDoS service. So Azure offers two main tiers of DDoS protection. Why I'm not mentioning basic here, because basic is for everyone. You need not to go and enable basic from portal or from anywhere. It is available for everyone. But standard, which is like it used to be standard, which is further segregated as, or not exactly segregated. The standard one is the DDoS protection, network protection. IP one is the new, not new for everyone, but as compared to the standard. So there is two offering, you could say, DDoS network protection and DDoS IP protection. And DDoS protection basic is for everyone, which is automatically enabled and for Azure infrastructure. But for standard, this tier, standard or network protection, this tier offers enhanced DDoS mitigation feature for virtual networks and is a paid service, right? Just like IP protection is also a paid service. But it protects the public IP address that you owns on which your application is running, and it protects your virtual network. Basically, these two protects almost the same thing apart from the last four things, you could say. Network protection also protects the basic public IP, but DDoS IP does not. You see no here. DDoS rapid response support is provided by network protection. Cost protection provided by network protection. What is cost protection? How could you protect the cost? It is like if you are under attack and if you have protection, all those resources which were consumed to fight with that attack, Microsoft will provide you some what we say cost protection over that. They will help you, or they will not charge you for the extra resource that you need to spin up or work on when you're fighting with the that attack. And of course, there is a WAF discount if you go with the network protection, but not with the IP protection. Rest is all the same, you could say. People usually get confused like DDoS IP protection is only for the public IP. No, no, no. It is also for L3, L4 automatic attack mitigation. You see here, right? And of course, there is a difference in the pricing that we will see in the next slide. All right, let's see. Okay. Before we talk about the pricing, there are some key features that we should understand, which is something which will help you to understand what exactly these DDoS protections are giving you and how they are actually protecting your resources on Azure. The very first thing is Azure watches over your application's internet traffic all the time, day and night, to spot any signs of DDoS attacks. When it finds an attack, it quickly steps in to stop it without you having to do anything. Always monitoring. Azure learns how your app normally gets internet traffic and adjusts its protective measures to fit your app best. As your app's traffic changes, Azure keeps adapting to protect it. So it's a smart adjustment, adapt itself, real time. Okay. Then Azure sets up like three special rules for different types of internet traffic to protect each public internet address of your app. These rules get smarter and adjust on their own using technology that learns from your application's internet traffic. If the traffic hits a certain limit showing there is an attack, Azure steps in to protect your application. You get detailed updates every 5 minutes. Okay, so when there is an attack happening and a summary report after it's over, you can watch these updates live in tools like Microsoft Sentinel for a close look at what's happening. And you can see a summary after then an attack, what happened during the attack in Azure Monitor. Plus, you can set up alerts to let you know when an attack starts, while it's happening, and when it stops. If your app is under attack, you can get help from Azure DDoS Rapid Response, which is a Microsoft team. There are they are there to help figure out the attack and give advice on what to do next. You can quickly create a ticket, support ticket from Azure portal as a critical. It gives you option just like any other ticket, but from the DDoS service, and you have your team ready. Azure DDoS protection is built right into Azure, making it easy to turn on through the Azure portal. We'll show you in the Azure portal how exactly it works. It is like easy to use, just turn on key, turnkey protection. And it is a native platform integration that we talked about. And turning on DDoS protection means your whole virtual network is immediately guarded against attacks. You don't have to set anything up or make any changes. It's all automatic. All right, and it gives you protection on multiple levels when used with a WAF. Azure DDoS protection guards your application from internet traffic attacks L3 and L4, and attack aims at the app itself layer 7. So you gotta use WAF along with the DDoS to protect your layer 7 traffic. Azure offers its own WAF, we all know, through the application gateway, and it is a wonderful gateway or a smart load balancer along with the wonderful security feature of WAF. Azure can handle any type of DDoS attacks, even the biggest ones known, with its global resource availability, right? And cost protection, cost guarantee that we already talked about. If your app gets attacked and you end up using more Azure resources to handle it, Azure might cover those extra costs for you. But it comes with the Azure network protection only. All right, so let's see what do we have. Pricing. Oh, before we do the pricing, I think I should show you, or maybe we'll show you in the end how to enable it. So pricing. For network protection, the monthly charge is 2944 per month, but it covers 100 public IP. But you can add as many virtual network or different subscription to this network protection as well. But the count happens through the public IP. And for IP, it's 199 per month for single IP addresses. So let's take an example to understand it better. Let's suppose there is a virtual network with 10 public IP address. Okay. If it's a network protection, let's assume you have only one subscription in your tenant. You create a network protection plan. The plan includes protection of 100 public IP addresses. That subscription will be billed how much? 2944. And let's take in the same scenario and assume you have 10 public IP address. You have enabled IP protection. And it would be 1990, right? 10, 1990. So under this scenario, it's more cost effective to enable IP protection for each public IP address. For environments more than, I guess, 15 public IP address, it's more cost effective to create a network protection plan if the cost is the decision factor for your environment. All right, so let's see. Oh, we are almost done, but I would like to show you how to enable this on Azure. Let's suppose this is our Azure. You need to go to DDoS, and here you can create the DDoS plan. The only thing you need to do, because it is very expensive that I show you, so I won't create it. You just need to provide the name and it will get created along with the resource group, right? Now, how will you enable on the virtual network? Let's go to the virtual network. Go to the virtual network and you will see DDoS protection here. You can enable it from here because you don't have any plan here, but if you would, you can simply use the plan that you have created. If it is a different subscription, you can use the resource ID as well. All right, now what about the public IP? Let's go to the public IP addresses. Now remember, if I go to this public IP address, I will not see anything. As you can see, DDoS protection not connected to backend server. That's why it's saying. Let's go to a different IP address. This is again a public IP address. We are not getting any option here. It's not even saying you're not connected to any backend. Why is that so? If your guesses are this, like it's a basic script, that's why. Because if you remember, we showed this in the comparison tier at the very second or third slide. But if it's a standard IP, as you can say, you can enable it from here. But it's not connected to the backend, that's why it's saying this. But that's how you can connect it on the public IP. So with this, it's time to end the video. Let's meet in another one with some interesting topics, maybe related to the DDoS, security, and other features, or maybe something else. Let's see. Till then, take care and bye-bye.